Okay, in this video we're going to talk about surds. Okay, I've written some important properties of surds. Once again, I've tried to make it as simple as possible. So the first one says square root of a times square root of a, okay, is square root of a squared, which is just a, okay, and that's pretty common sense there. If it's a different value, square root of a times square root of b, you can actually put it all on the one square root, so square root of a times b, and the converse is also true. If you have a times square root of b plus c times square root of b, since those two are the same, okay, they're the same surds, okay, this is similar to algebra, similar to like terms, we can add a and c, only if the surds are the same, okay, add or subtract only if the surds are the same, so a plus c times square root of b. With multiplication, we don't have to, okay, this is a times square root of b times c times square root of b. Well, square root of b times square root of b is square root of b squared, which is just b, and a times c is ac. Square root of a squared times b. Now, if we use this second rule for this one, we can separate this and write it as so. And this comes back to the first rule, so we just get a square root of b. For division, it also works. If you have a rational function under one square root, you can separate it and separate the square root signs. Okay, so that's the same with times, okay, number 2 and number 6. And if we have a binomial expansion, okay, it's the same method, okay, just be careful with your multiplying. So square root of a times square root of c, square root of a times square root of d, square root of b times square root of c, and square root of b times square root of d. Okay, and then you simplify. So let's look at some examples. Okay, I've written some examples down here, and there's also another page of 2 more. So let's get through these. Okay, once again, you guys can copy them down, learn them yourself. You can pause the video, have a go, and see if you get it right. Okay, you guys know how to study. Okay, this is merely just to help you guys out. Okay, square root of 75. If we think about the factors of square root of 75, I can write 25 times 3. Okay, that's true. 25 times 3 is 75. If we go back to our properties, I have a times and I have square roots, so I can separate it. I can do that. And the reason I picked 25, okay, because 25 is a perfect square, so square root of 25 is 5 root 3. And that's your answer. That's your simplification. Don't give a decimal answer. If you press this on your calculator, it'll give you a decimal. Okay, it won't give you this because our calculators, the one that are approved by the HSC, the Board of Studies, HSC approved calculators, are not programmed to give exact values. Okay, other ones are, but if you have the Casio FX82 AU Plus or AU Plus 2, it will not give exact values. Okay, if you have the ES1, which is not approved by the HSC Board of Studies, it will give exact values. So that's just a little tip there. Okay, the next one, square root of 8 plus square root of 2. Notice that just before I go on, this method here, from there to there, does not work if that's a plus. Okay, this only works from there to there, only works if it's a times or a divide. It won't work if this was 25 plus 3. You can't write square root of 25 plus square root of 3. Okay, so get that out of your head. That won't work. So this next one, square root of 8. Notice square root of 8 I can write as 4 times 2. And I haven't done anything to this root 2 yet. I can write this like this. Square root of 4 is 2. Okay, this is like a 1 there. I have the same surd, so I can add 2 plus 1, and I get 3 square root 2. Okay, for that one. If you guys have any trouble, if you get stuck on something, just shoot me an email. If you see any errors in my working out, send me an email as well. Let me know there's an error, and I'll fix it up. Hopefully there isn't any. Okay, the next one, C. Square root of 5 times 2 times square root of 5. This is one is actually pretty easy. Okay, this is all getting times. So square root of 5 times square root of 5 is 5, and then we're timesing by 2, so pretty cinched that one. Okay. Gets a little bit harder with the next one. Okay, I want to simplify this. So let's start breaking down our surds. So 18 can be written as 9 times 2. 8 can be written as 4 times 2. And 12 can be written as 4 times 3. Now you can see why I picked 9, 4, and 4, because they're perfect squares. So this can be written as 2 times square root of 9 times square root of 2 minus square root of 4 times square root of 2 plus square root of 4 times square root of 3. This gives 2 times square root of 9, which is 2 times 3 times square root of 2, minus 2 times square root of 2, plus 2 times square root of 3. And I get 6 square root of 2 minus 2 square root of 2 plus 2 square root of 3. I can only subtract this. I can't subtract this because it's not the same surd. So I end up getting 4 square root of 2 plus 2 square root of 3. Okay, just leave your answer like that. You can always factor out a 2 and make it fancy, but okay, that'll be your final answer there. Okay, and two more examples. Okay, here is this one. We want to expand. Okay, so I have square root of 2 times square root of 8, square root of 2 times minus square root of 9. Okay, so let's go ahead and multiply this. Okay, 2 times 8 minus square root of 18. Okay, we know square root of 16, which is 4. Let's separate 18 like so. Okay, and we end up getting 4 minus 3 root 2 for that one. Okay. The next one is a binomial expansion. Okay, so, and all of them work the same. If there was negatives, I just picked this one just out of my head. So, I mean, they all work the same. So when you guys come to your exercises, in questions in the exercises, they all work the same, as I'm going to show you this one. So we're going to go square root of 3 times square root of 3, which is just 3. Square root of 3 times 1, which is square root of 3. 2 times square root of 3, which is 2 root 3. 2 times 1, which is 2. Okay, notice that we have square root of 3 and square root of 3. So we can add that, and also we have 3 plus 2. So here we get 5 plus 3 square root of 3. Okay, so pretty easy binomial expansion there. Okay, that's it. Shoot me an email if you guys have any questions.